In the previous video, we actually showed you the transformation of the X domain, alright, and then deriving the beam stiffness matrix. And in the last two videos, we actually proved to you in terms of a C domain, alright, the curl C, alright. But what is exactly the shape functions, alright? Well, how is it different from, and how is it intuitionally understood, alright? Is that the first thing for this case, for the in terms of the X domain, alright, we want X cube, a cubic polynomial. It's because the cubic polynomial is something like this, alright. It's not a quadratic. Alright, quadratic is something like this, while the cubic polynomial is more than that. It's something like this, okay. And this cubic actually demonstrated a good way to signify the beam's bending, or to represent the beam's natural bending in such of a manner. So therefore the cubic is something that we want to look at, and therefore we use cubic, alright. And therefore you have something like of this shape like this. But however, you want it to stop over here only, so therefore you need some other stuff to let it be, to cancel off this to become 0. So for example, we have a beam node 1 and node 2, alright. This is your beam over here, and then you have 0 and your length of the beam, okay. Hopefully you understood. So therefore, if my case, if I have a node at 1, alright, so my shape functions at x1 is actually 0, and x2 is okay, yeah, for x, this is x1, this is x, because it's in the one direction, two direction. So x1 at node 1 is equals to 0, x1 at node 2 is equals to L. So in this case, if it says node 1, it is equals to 0, and therefore this whole thing becomes 0, because 3 times 0 is simply 0, right? 0, so 1 minus 0, you have only 1, right? So 1 minus 0 is just 1. Therefore you have this thing over here. So your shape functions n1 is this one, the blue color one. Okay, and then since we know that it's blue color, you know that if it's for the node 2, it should be in terms of 0. So you can just simply sub it in. So if x is equals to L, the length of the beam, you have something like this. Alright, so L squared cancel with L squared, L cube cancel with L cube. You have 1 minus 3, this thing will becomes minus 2 plus 2 equals to 0. Alright, so therefore at this point is 0. Alright, same thing for others. Okay, for the shape function 2 is something like this, but we have a certain angle. I don't know how the angle comes in, but yeah. And then shape function 3 is simply the opposite of shape function 1. Okay, things like that. Alright, but at least you get to know that how the curvature is being plotted out in such of a manner. But the end in mind is to have a cubic system, alright, to better represent your beam bending. Likewise, for the C domain now, this in terms of C is from -1 to +1. So when you sub in your C, you're going to sub in terms of -1 or +1. In this case, if I'm looking at this point over here, if I sub in -1 times -3, you have +3, and then -1 cube is actually -1, alright, because cube, if you square it, it becomes 1, 1 times -1 is still -1. I think you get what I mean. Alright, but so 2 plus 3 is 5, 5 minus 1 is 4. Alright, so this whole thing over here becomes 4. So 4 over 1/4 is equals to 1. Therefore this whole chunk over here is your 1. It's your shift functions over here, this line. If you sub in as, alright, +1, you should get 0 also. Okay, I just want to prove to you and show you that this is how this is being applied into the graph itself. Alright, so if let's say they give you some point, okay, let's say they give you this point over here. They say that this is the C function over here, and they call you to find your displacement U. Alright, then you can sub in your this C, and then you sub in individually for all of these shape functions. Alright, and see how the displacements go. Alright, so you have like n1 u1 plus n2 u2. Then for u4 is equals to your overall u. Okay, where you can also rewrite as n and then ui, n transpose, I would say, yeah. Okay, so your overall displacement will be something written in this manner. Okay, so therefore this is some concept that I just want to convey to you. Okay, and you may wonder that what is actually this thing. Alright, This thing over here is the Kronecker delta. It's just telling us that if this is for like n1 shift function 1 at node whatever. At node 1 then it's this one, right? At node 1. This is node 1, right? Node 1. This is node 2. So it's just telling you that if the shift function is at node 1, if the shift function 1 at node 1, then you have equals to 1, alright, which is shown over here lah. If it's not, then it's just simply 0, alright. So what I mean is that if it's at node 1, if it's shift function 1 at node 2, you know that it simply equals to 0, because at node 2, your shift functions, your n1 is actually 0, right? It's over here. So therefore, it's just some of the indications, but you just to embrace you with more awareness of it. Alright. So this is just the few stuff. So later on we'll highlight a few summary of the important stuff that we need to look at. I shall see you there.